Hello and welcome, this is Majid, and in today's video we will be solving multiple choice question from paper 1 variant 2 of May-June 2020. If you want to go to a particular question, just follow timestamp given in the video description. Let's start. Question 1, in which carbon allotrope are all electrons localized? Now localized means that the electrons are fixed. We can see there are two types of covalent bond. One is sigma covalent bond and another is pi covalent bond. In sigma covalent bond, electrons are always localized because they are fixed between the two atoms. They cannot move freely, while pi electrons can move freely. So there are four options: Buckminster fullerene, diamond, graphite and graphene. Let's find out the number of sigma bonds in each of these. So in Buckminster fullerene, carbon makes 3 sigma bonds. In diamond, carbon makes 4 sigma bonds. In graphite, again we have 3 sigma bonds. In graphene, we have 3 sigma bonds. Now the fourth electron in Buckminster fullerene, graphite and graphene is not localized. It is delocalized. So the only option in which all electrons are localized is B, diamond. Question 2. A copper ore contains 3% of copper carbonate by mass. Which mass of copper would be obtained from 1 ton of the ore? We can also write 1 ton as 1000 kilograms. First, they have given the ratio between the ore and copper carbonate. So they say that only 3% of copper carbonate is present in 100% ore. So we have 100 ratio 3. Now in the question we have 1 ton of the ore. So let's find out how much copper carbonate will be present in 1000 kilograms or 1 ton of the ore. So we have X, just cross multiply 1000 into 3 divided by 100. So the answer is 30 kg. So we have obtained 30 kg of copper carbonate from 1 ton of the ore. Now let's find out how much copper will be present in copper carbonate. So we can find the ratio between copper metal and copper carbonate. According to the atomic masses, we know that 63.5 grams of copper is present in 63.5 plus 12 plus there are 3 oxygen atoms, so it is 48. So the total is 123.5. So the ratio is 63.5 grams in 123.5 grams of copper carbonate. We can also say that 63.5 kilograms of copper is present in 123.5 kilograms of copper carbonate. In the question we have 30 kilograms of copper carbonate. So let's find out the mass of copper in 30 kilograms of copper carbonate. We can again cross multiply. So X will be 63.5 into 30 divided by 123.5. So it comes to be 15.42 kilograms of copper. So it means that the answer is part C. Question 3. The catalyzed formation of ammonia by Haber process can be represented by the equation shown. This is an exothermic process, so therefore the enthalpy change is negative. Which change in conditions will increase both the rate of formation and the equilibrium yield of ammonia? So we have to find out what changes the rate and also the equilibrium yield. A says decrease in the temperature. Now as the reaction is exothermic, so in order to obtain greater yield we need lower temperature. But what happens that when we decrease the temperature, actually the reaction slows down. So therefore the rate of formation will also decrease with the decrease in temperature. B is increase in the temperature. If we will increase the temperature for an exothermic reaction, the reaction is going to be moving backwards, which actually decreases the equilibrium yield of ammonia, so therefore B is also not the option. C says increase in the pressure. Now let's find out the number of moles. We have 1 mole of nitrogen gas, 3 moles of hydrogen gas and 2 moles of ammonia gas are present in the product. We know that whenever the pressure is increased, the reaction moves from more number of moles to less number of moles, or in this case more product is formed. And also pressure can also increase the rate of reaction because the molecules just come close together and there are more number of effective collisions. So therefore increase in pressure can increase both the rate and also the equilibrium yield of ammonia. D says increase in the surface area of the catalyst. Now increasing the surface area of the catalyst does not increase the equilibrium yield, it only increases the rate of formation. So therefore the only option is C. Question 4. Solid sulfur consists of S8 molecules. Which equation represents the standard enthalpy of atomization of sulfur? Now according to the definition, we know that the standard enthalpy change of atomization is the enthalpy change when 1 mole of gaseous atoms is formed. So let's find out in which equation are 1 moles of gaseous atoms being formed. So this is 1 mole, this is 1 mole, this is 8 number of moles, this is also 8 number of moles. Second part of the definition says that from its element under standard conditions. So we know that in standard conditions sulfur is present in solid form as compared to the gaseous form. So therefore answer is part A. Question 5. In this question you should use changes in oxidation numbers to balance a chemical equation. The following reaction occurs when manganese dioxide is warmed with dilute sulfuric acid. What is the ratio of C ratio D in the correctly balanced equation? So we have to find the ratio between the manganese ions and manganate ion. Let's first find out the oxidation state of manganese in both manganese dioxide and manganate ion. As we know that the overall charge in MnO2 is 0. So Mn, there are 2 oxygen atoms. The charge on the oxygen atom is -2 and the overall charge is 0. So we have Mn -4 is equal to 0 or Mn is equal to +4. So the oxidation state of manganese in MnO2 is +4. In MnO4- we have 1 manganese atom, 4 oxygen atoms, 4 into -2 and the overall charge is -1. So the oxidation state of Mn is +7. Now in this equation we can see that manganese is being oxidized to +7 and also being reduced to +2. So we can write both chemical equations, first for oxidation and second for reduction. So in oxidation MnO2 actually converts into MnO4-. In reduction we can see that MnO2 is being reduced to Mn+2. First step is to balance the atoms other than oxygen and hydrogen. So we have Mn and Mn balanced in this equation. We also have manganese balanced in this one. The second step is to balance the number of oxygen atoms by adding water molecules on the side having less number of oxygen atoms. So let's add H2O to this side. Now we have to add 2 water molecules in order to balance the 4 number of oxygen atoms. In this equation we can balance by adding 2 number of water molecules so that the number of oxygen is balanced on both sides. As this equation is in acidic medium, so we have to balance the number of hydrogen atoms by providing hydrogen ions on the opposite side. In the reactant side, we have 4 number of hydrogen atoms, so we can balance that by providing 4 protons. For second equation, we also have 4 number of hydrogen atoms, so we can balance that by providing 4 H plus ions. Now in the next step, we have to balance the charges. We have -1 for MnO4, we have 4 plus or +4 for H plus ions. So the overall charge for this equation is +3. So we can add the number of electrons in order to balance the charges. On the reactant side, we have 0 charge because both the water and MnO2 is neutral. So we can add 3 electrons so that this part also becomes neutral. In the second equation, we have +4 charge and 0 charge on MnO2, +2 charge on Mn and 0 charge on water. So we can add 2 number of electrons to the reactant side in order to balance the charges on both the sides of the equation. Now we can see that 3 electrons are lost in one equation and 2 electrons are gained in the second equation. As in balancing, the number of electrons lost should be equal to the number of electrons gained, so we can multiply this equation by 2 and this equation by 3. Now after multiplication, we will have 4 molecules of water, 2 MnO2, 2 MnO4 minus 8 protons and 6 electrons. For the second equation, we will have 12 H plus, 3 MnO2, 6 electrons, 3 Mn plus 2, 6 water molecules. As now both the equations are balanced, so we can see that the ratio between Mn plus 2 and MnO4 minus is 3:2. So the answer should be D. Question 6. In this question, you should assume air contains 21% oxygen. What is the minimum volume of air required to ensure complete combustion of 10 cm3 of butane gas under room conditions? Let's first write the combustion equation for butane. We know the formula of butane is C4H10. It combusts in the presence of oxygen to form carbon dioxide and gas and water. Now we can balance the number of atoms. There are 4 carbon atoms on the reactant side, so we can write 4 with CO2. There are 10 hydrogen atoms on the reactant side, so we can write 5 with H2O. In the products, we have 8 number of oxygen atoms in carbon dioxide and 5 in water molecule. So total we have 13 atoms of oxygen. In order to balance oxygen, we can write 13 by 2. Or we can also write 6.5 moles for oxygen. Now we can see that the mole ratio between butane and oxygen is 1:6.5. So we can also say that 1 volume of butane requires 6.5 volumes of oxygen gas. So for 10 cm3 of butane gas, we would require 65 cm3 of oxygen gas. In the question, they have asked about the air, not the oxygen, so we can find out the ratio between air and oxygen. In the question, they have given that in 100% of air, we can assume there is 21% of oxygen. So by volume, we can say that 100 cm3 of air will contain 21 cm3 of oxygen. Now 65 cm3 of oxygen will be present in how much air? We can cross multiply and find the volume of air required for the complete combustion of butane. So X is equal to 100 into 65 divided by 21. So the answer is 309.5 cm3 of air. So therefore the option is D. Question 7. When aqueous bromine is shaken with cyclohexane and allowed to stand, two layers are formed. The top cyclohexane layer is colored and the bottom aqueous layer is almost colorless. What is the most likely explanation for this observation? A. Bromine is reduced to bromide ions in the bottom layer. As we know that the bottom layer is of H2O and bromine does not react with H2O, so therefore it is not reduced and therefore this option is incorrect. B. Bromine molecules are nonpolar. Yes, bromine molecule is nonpolar because there are no opposite charges. Both are bromine atom, both have similar electronegativity, so therefore the molecule is nonpolar. This could be correct. C. Bromine reacts with water but cannot react with cyclohexane. Bromine does not react with water, so therefore this is wrong. D. The product of the reaction between bromine and cyclohexane is colored. Bromine does not react with cyclohexane, so therefore this is also wrong. Bromine just dissolves in cyclohexane. So there is no reaction and no products. So therefore D is also incorrect. So the answer is B. Question 8. In which change are only temporary dipole-induced dipole forces overcome? As we know that temporary dipole-induced dipole is only present in non-polar molecules. So let's first find out which are the non-polar options. A is alcohol. In alcohol, oxygen is partial negative and hydrogen is partial positive. So therefore it is polar. Water is also polar because there is hydrogen bonding between water molecules and there are opposite charges, partial negative on oxygen atom and partial positive on hydrogen atom. Oxygen is nonpolar because it's a molecule and there are no opposite charges. C4H10 is also nonpolar because there is not much electronegativity difference between carbon and hydrogen. So therefore it could be C or D. Now the question says in which change are only temporary dipole-induced dipole forces overcome? As oxygen is converting from solid to liquid form, so therefore the forces are being overcome. While alkane is converting from liquid to solid form, so therefore the forces are not overcome. Actually there are more forces of attraction. So the only possible option is part C. Question 9. The complete combustion of 2 moles of an alkane produces 400 decimeter cube of carbon dioxide measured at 301 Kelvin and 1 exponential 5 pascals. Carbon dioxide can be assumed to behave as an ideal gas under these conditions. What is the formula of the alkane? Now let's first write the chemical equation for combustion of alkane. We can write alkane as CxH2x plus 2. It reacts with oxygen to form carbon dioxide and water. Now in the question they have already given the number of moles of alkane, so there are 2 moles of this alkane being burnt. Now the volume of carbon dioxide is given. Let's first find the number of moles of carbon dioxide. So we know that according to ideal gas equation, PV is equal to nRT, where n is the number of moles. So n will be P into V divided by R into T. Now the pressure is in pascals, so we can write 1 exponential 5. Volume is in meter cube, so we can convert decimeter cube into meter cube by dividing by 1000. The value of R is 8.31 and temperature is given in Kelvin. It is 301 kelvins. Now the number of moles of carbon dioxide comes to be 16 moles. So we can say 16 moles of carbon dioxide molecules are being formed. Or we can also say that 16 moles of carbon atoms are produced. as they have given the number of moles of the reactant. So therefore, in order to make 16 moles of this reactant or 16 moles of carbon atoms in this reactant, the X value must be equal to 8, because 8 into 2 will be 16. So therefore the name of alkane or the formula of alkane is C8H18. Therefore answer is part A. Question 10. In which reaction does an element undergo the largest change in oxidation number? So we have to find out the oxidation numbers of all the elements present in these options. In A, we have chlorine molecules, so the oxidation state is 0. For chloride ion, we have -1. For hydrogen in water, hydrogen is always +1 and oxygen is always -2. Let's find out the oxidation state of oxygen and hydrogen in hydroxide and oxychloride ion. So in OH- ion, we have -2 for oxygen and the overall charge is -1. So the charge on hydrogen is +1. So it is -2 for oxygen and +1 for hydrogen. For OCl, we can find out like this. The oxidation state of oxygen is -2 and the overall charge is -1. So chlorine is equal to +2 -1 +1. The oxidation state of oxygen is -2 and chloride is -1. Now part B, chlorine again in molecular form, so therefore oxidation state is 0. For hydroxide ion, we have -2 for oxygen, +1 for hydrogen. For chloride ion, we have -1. For water, we have +1 -2. Let's find out the oxidation state of chlorate ion, ClO3-. So we know that the oxidation state of oxygen is -2. There are 3 oxygen atoms, so the total charge is -6. Overall charge is -1. So chlorine -6 -1. Chlorine is equal to +6 -1 +5. So we have +5 charge for chlorine atom and -2 for oxygen atom. For C, we have Cr2O7. The oxidation state of iron is +2. For H is +1. For chromium it is +3. For iron it is +3. For water it is +1 and -2. Now let's find out the oxidation state of Cr2O7-. So there are 2 chromium atoms, 7 oxygen. For 7 oxygen, the total oxidation state is -14. Overall charge is -2. Now the charge on one chromium atom will be +6. So the oxidation state of chromium is +6, oxygen is -2, and the rest are given. Now part D, we have MnO4 -2, H is +1, MnO2. In MnO2, Mn is +4, oxygen is -2. In water, hydrogen is +1, oxygen is -2. Now in MnO4 -2, we have 4 oxygen atoms. So the oxidation state of manganese is +6. So we have +6 for Mn, -2 for oxygen, +1 for hydrogen. In MnO4, we can also find the oxidation state of Mn. There are 4 oxygen atoms and the overall charge is -1. So the oxidation state of Mn is +7. Now let's find out the differences between the oxidation state change. So we can see that chlorine changes from 0 to +5, and this is the largest change in oxidation number. So therefore option is B. Question 11. PCl5 decomposes as shown in this equation. 1 mole of PCl5, 1 mole of PCl3 and 1 mole of Cl2 are placed in a container of volume 1 decimeter cube at 250 degrees centigrade and allowed to reach equilibrium. At this temperature, the equilibrium mixture contains 1.8 moles of PCl3. This is the amount of PCl3 in equilibrium. What is the value of Kc at 250 degrees centigrade? Let's rewrite the chemical equation. We have PCl5 and it is converted into PCl3 along with Cl2. Now the initial concentration is 1 mole for PCl5, 1 mole for PCl3 and 1 mole for Cl2. Second is the change in concentration. We'll find it later. And third is the equilibrium concentration. Now at equilibrium, the question says that the mixture contains 1.8 moles of PCl3. Now the moles of PCl3 are 1.8. As the number of moles of PCl3 and Cl2 is equal, so therefore Cl2 must also be 1.8 at equilibrium. Let's find the change in the number of moles. So we can see that PCl3 changes from 1 to 1.8 and therefore the change in the number of moles is plus 0.8, or you can say that 0.8 moles are increased in the number of moles of PCl3. So therefore same amount of moles will be decreased from PCl5, so it will be 1 minus 0.8, and for Cl2 it is also an increase in 0.8 moles. So therefore at equilibrium we can write 0.2 moles of PCl5 are left, 1.8 moles of PCl3 is present and 1.8 moles of Cl2 is present. According to the formula of equilibrium constant expression, so Kc will be equal to the concentration of product PCl3 Cl2 divided by concentration of the reactant PCl5. Now as we know that the volume given here is 1 decimeter cube, so therefore the number of moles is also the concentration. Just putting the values, we have 1.8 into 1.8 divided by 0.2. So the value of Kc comes to be 16.2. So therefore the answer is part D. Question 12. The 5th to 8th ionization energies of 4 elements in period 3 of the periodic table are shown. Which row refers to chlorine? For chlorine atom, we know that there are 7 electrons in the outermost shell. So for ionization energy, basically the number of electrons are removed one by one. When this is first ionization energy, the first electron is removed. For second ionization energy, second electron is removed, and so on. For 7th electron, it must be 7th ionization energy. Now after removal of 7th electron, the whole shell is actually lost. So therefore we have inner shell that is present. So the 8th electron will be removed from the inner shell. Therefore there will be a larger jump from ionization energy of the 7th electron and the ionization energy of the 8th electron, which is in the inner shell. So let's see the difference between 7th and 8th. We have 25,000, 30,000, 27,000, 31,000, 11,000 and 33,000. Now this jump is the larger value, 12,000 to 13,000. So the only option in which there is a larger gap or the larger jump between the ionization energy of the 7th electron and 8th electron is C. So therefore it is the correct option. Question 13. Magnesium nitrate decomposes when heated to give a white solid and a mixture of gases. One of the gases released is an oxide of nitrogen, X. 7.4 grams of anhydrous magnesium nitrate is heated until no further reaction takes place. What mass of X is produced? Let's first write the balanced chemical equation for this decomposition. We have magnesium nitrate. It decomposes to give an oxide along with an oxide of nitrogen and oxygen gas. To balance this equation, we can have 2 moles, 4 moles and 1 mole of oxygen. Now this equation is balanced. For ease, you can actually remember this ratio of moles in this balanced equation. It is 2:4:1. According to this equation, the ratio of moles between magnesium nitrate and nitrogen dioxide is 2:4. Let's first find out the moles of magnesium nitrate given in the question. The number of moles is actually mass in grams, which is 7.4 grams divided by molecular mass. Now putting this number of moles in the ratio, we can find 0.049 moles of magnesium nitrate reacts with X number of moles of NO2. So by cross multiplying, we can find the value of X 0.049 into 4 divided by 2. Now the number of moles of X comes to be 0.099 moles of NO2. X is actually NO2. Now in the question they have asked what mass of X is produced. So simply use the formula of mass. Mass in grams is equal to moles into molecular mass. Number of moles is 0.099 and molecular mass of NO2 is 14 plus 32. So therefore mass in grams is 4.59 grams. Therefore answer is D. Question 14. Which statement explains why iodine is less volatile than chlorine? Now volatility actually depends on the intermolecular forces of attraction. If the intermolecular forces of attraction are strong, then the substance will be less volatile. If the intermolecular forces are weak, then the substance should be more volatile. Let's find out the answer. Part A says chlorine is more electronegative than iodine and so has more repulsion between its molecules. As volatility does not depend on the electronegativity, it only depends on the intermolecular forces, so therefore this option is incorrect. B says the greater number of electrons in iodine leads to a larger temporary dipole-induced dipole forces. We know that if the number of electrons are larger, so therefore there will be more temporary dipole-induced dipole intermolecular forces, and higher the forces, then it tends to be less volatile. So therefore iodine is less volatile, and also you can observe that iodine is in solid form while chlorine is in gaseous form. So this is all because of the intermolecular forces. C says the II bond energy is smaller than the Cl-Cl bond energy. When measuring volatility, we do not break the bond, so therefore this option is incorrect. The iodine molecules have stronger permanent dipole-dipole forces. Now permanent dipole-dipole forces are only present in those molecules which have poles in between them, partial positive and partial negative charges. As there are no partial positive and partial negative charges in iodine, so therefore this is also incorrect. So therefore the only correct option for this question is part B. Question 15. Ammonium carbonate is a crystalline solid. On gentle warming, a reaction occurs forming ammonia as one of the product. How are the carbonate ions behaving during this reaction? Let's first write the balanced equation or just the chemical equation for this type of reaction. We have ammonium carbonate. It decomposes to give ammonia, water, and carbon dioxide. As we know that in ammonium carbonate, the charge on NH4 is +1 and the charge on carbonate is -2. In the product you can see ammonia is formed. So therefore we can say that one H+ is lost from ammonium ion in order to make NH3. and this H plus ion combines with oxygen to form H2O. It means that ammonium ion is proton donor and carbonate ion is proton acceptor. So according to the definition, Bronsted Lowry acid is actually the proton donor. Bronsted Lowry base is proton acceptor. As the carbonate ions are actually accepting protons, so therefore B could be the possible option. Now in C we can see oxidizing, and in D we can see which one is oxidizing or reducing agent. So let's find the oxidation states. In NH4 plus 1, the oxidation state of nitrogen is -3 and of hydrogen is +1. Also in ammonia we have -3 oxidation state for nitrogen and +1 oxidation state for one hydrogen atom. As you can see, the oxidation state of nitrogen has not changed, so therefore carbonate does not behave as oxidizing or reducing agent. C and D are also incorrect. The only option that is correct is part B. Question 16. One molecule of an oxide of element Z reacts with 6 molecules of water to produce an acidic compound. What is element Z? Let's first find out which oxide does react with water. So aluminum oxide, it does not react with water. Phosphorus oxide, it reacts with water to produce acidic solution, so it could be phosphorus. Silicon dioxide does not react with water. Oxide of sulfur also produces acidic solution. Now let's write the balanced chemical equation. Phosphorus oxide is P4O10. It reacts with water to produce phosphoric acid. As we know that there are 6 molecules of water, so it will be 6H2O. In order to balance the hydrogen, we have to put 4. Now 12 hydrogen are balanced on either side. Then the number of phosphorus is also balanced and the number of oxygen is also balanced. So it means the ratio between water and phosphorus oxide is 1:6. So one molecule of phosphorus does react with 6 molecules of water. So the possible option is B. Let's write the balanced chemical equation for the oxide of sulfur. We have sulfur dioxide. It reacts with water. It forms H2SO3. As we know that there are 6 water molecules, now balancing the number of hydrogen atoms on the product. The ratio is 6:6. So the only option that is correct is B. Question 17. Which property shows an increase from magnesium to barium? Now magnesium and barium both belong to group 2 elements. A says the first ionization energy of the elements. In group 2 elements, as we move down in the group, the size of atom increases and therefore the ionization energy of the elements decrease. So A is incorrect. B says the oxidizing power of the metals. Now as we move down the group, the metals easily lose electrons, so therefore their reducing power increases. The oxidizing power actually decreases. C says the solubility of the hydroxides. Now we have seen the trend in the solubility of hydroxides, that magnesium hydroxide is less soluble as compared to barium hydroxide, because barium hydroxide is more alkaline as compared to magnesium hydroxide, so therefore the solubility increases. The solubility of the sulfates, it also decreases down in the group 2, and we know that barium sulfate is almost solid. It does not dissolve in water. So the only correct option is part C. Question 18. A test tube of HBr and a separate test tube of HI are heated to the same temperature. Which combination of observations is possible? Now we know that in hydrogen halides, HF is the strongest bond and HI is the weakest bond. This is because of the electronegativity difference. The bond strength decreases. As the bond strength decreases, so it is easy to decompose HI as compared to HBr. When HI is decomposed, it converts into hydrogen and iodine. The color of iodine is purple. Therefore, the only option that is correct is D. Question 19. Most modern cars are fitted with catalytic converters in the exhaust system. Which three gases are removed by the catalytic converter? As we know that in catalytic converter, gases like carbon monoxide, nitrogen monoxide and unburnt hydrocarbons are actually converted into harmless gases. CO and NO is converted into CO2 and N2, and unburnt hydrocarbons are converted into carbon dioxide and water. So we have A, carbon monoxide, hydrocarbons, nitrogen oxides. B is carbon monoxide, carbon dioxide, nitrogen oxides. C is carbon monoxide, nitrogen oxide, sulfur dioxide. D is hydrocarbons, nitrogen oxide and sulfur dioxide. So the only possible option is part A. Question 20. Compound X is shown. We can see compound X consists of carboxylic acid, alkene and alcohol group. X is treated separately with sodium hydroxide aqueous and lithium aluminum hydride to give Y and Z. What are Y and Z? Now in the presence of carboxylic acid group, sodium hydroxide aqueous reacts to form sodium salt of carboxylic acid, and it will become COONA, where the sodium is positively charged and oxygen is negatively charged, and water molecule is also emitted. Sodium hydroxide aqueous does not react with alkene or alcohol, so the only product that is possible is this. Now in second part, they have reacted compound X with reducing agent like lithium aluminum hydride. Now in the presence of LiAlH4, carboxylic acid actually reduces to aldehyde first and then further reduces into alcohol. So the structure for Z would be this one. Alkenes and alcohol is unaffected by the presence of lithium aluminum hydride. Now we can see in the options, option A, both are correct, so therefore A is correct. Question 21. The table shows the molecular formula of three molecules P, Q and R. None of these molecules are cyclic. Let's first draw the structural formula for these three given compounds. First is CH4O, so we can write so the P is actually primary alcohol. For Q, we can draw so Q is carboxylic acid. And for R, so R is in aldehyde. Which molecules show a strong absorption between 1610 cm and 1750 cm in their infrared spectra? Now let's find out the infrared values from data booklet. We have carbon for aldehyde and ketone. It absorbs between 1670 to 1740 per centimeter. Second is carboxylic acid group. It absorbs between 1680 to 1730 per centimeter. Third is alcohol group. It absorbs between 3200 to 3600 per centimeter. Now in the given range, only two are possible. One is carbonyl carbon and second is carboxylic acid group. So Q and R are correct. Therefore, the option is C. Question 22. Which row correctly shows the type of mechanism of each of the two reactions? First reaction is of halogenoalkane with potassium cyanide. Second reaction is of ketone with hydrogen cyanide. For C2H5Br, we can write CH3CH2Br. In the presence of potassium cyanide, cyanide ion will come. There is a lone pair of electrons on carbon atom. Now bromine is electronegative, so therefore it will be partial negative and carbon will be partial positive. Cyanide will attack to the partial positive carbon and bromine will take both electrons and is removed in the form of bromide ion. The resulting product is CH3CH2Cn plus Br negative. So therefore this is substitution reaction, and as nucleophile is involved, so therefore this is nucleophilic substitution. So it could be either C or D. Now let's find out the mechanism for the ketone with HCN. CH3 carbonyl carbon CH3 plus HCN. Again we have partial negative charge on oxygen and partial positive charge on carbon atom. When this cyanide will attack the carbon atom, these electrons will move towards the oxygen atom. The product formed is CH3C, CH3. Cn is attached to the carbon atom. Oxygen becomes negatively charged and then oxygen attacks the H positive and then becomes alcohol. So the product is hydroxynitrile. We have OH group, cyanide group and CH3. Now in this reaction you can see that cyanide ion is being added, so therefore this is addition. And again nucleophile is involved, so therefore this is nucleophilic addition. So the only option that is correct is part D. Question 23. Ester X is shown. This is an ester. Ester X is hydrolyzed using aqueous sodium hydroxide. What is the molecular formula of one of the product? Now hydrolysis of ester takes place in such a way that the bond between this oxygen atom and this R group actually breaks. If sodium hydroxide is present in aqueous form, then the product will be RC double bond O, ONA, and second part will become alcohol. Now let's hydrolyze this ester X. We have CH3, C double bond O, CH2, 7, CH3. So it will be hydrolyzed in the presence of aqueous sodium hydroxide. And the product will be, the bond is broken from this place, CH3CO, O negative, Na positive, and second part will become alcohol. We have CH3, CH2, 7, OH. Now the molecular formula of both products is, first one is C2, H3, O2, Na. The molecular formula of second product is C8, H18, O. Now we can see that the only option that is correct is part B. Question 24. Which reagent could be used to distinguish between propane 1,2-diol and ethane 1,2-diol? Let's first draw the structures of both of these. We have propane, and on first and second carbon atom alcohol is present. So this is propane 1,2-diol. Then we have ethane 1,2-diol. There are two carbon atoms and two alcohol groups are present. A says alkaline aqueous iodine. This is the iodoform test in which CHI3 is formed. Now for positive test we need to have such an alcohol whose carbon atom directly combines with one of the methyl groups. So this surely gives positive result with alkaline aqueous iodine. while the other carbons does not give this result. So therefore propane 1,2-diol will give positive result and ethane 1,2-diol won't give. So this option could be correct. B says aqueous acidified dichromate. Now dichromate can oxidize both of these two compounds, compound A and compound B. C says ethanol and a few drops of concentrated sulfuric acid. With this reaction, both of these compounds A and B will form carbon dioxide gas. So therefore we cannot distinguish between them. D says sodium metal. Now sodium metal can also not be used to distinguish between A and B because both A and B will form sodium glycolate. So the only option that is correct is part A. Question 25. Which substance forms propanoic acid as one of the products when it reacts with hot concentrated acidified potassium manganate 7? They have given 4 options and all of them are alkenes. So for alkenes we must know how are they oxidized. So if double bonded carbon of an alkene is combined with 2 hydrogen atoms, then this will convert into carbon dioxide upon oxidation. So CO2 is formed. If the carbon atom which is double bonded in alkene is attached with one alkyl group and one hydrogen atom, so then this will convert into aldehyde first and then further oxidized into carboxylic acid. If double bonded carbon is directly attached to 2 alkyl groups, then this carbon converts into ketone and ketone is not further oxidized. So RC double bond O, R is formed. Now based on these observations we can find out what products are formed from either of these A, B, C or D. First is but-1-ene, so we can write CH2 double bond CH, CH2, CH3. This is but-1-ene as one of the carbon has 2 hydrogen atoms, so it will convert into carbon dioxide, and the other product is aldehyde and then further carboxylic acid. So the carboxylic acid will be CH3, CH2, COOH. Now this carboxylic acid has 3 carbon atoms, so it is propanoic acid. So this could be the possible answer. Now let's see part B. We have but-2-ene, CH3, CH, double bond, CH, CH3. This is but-2-ene because double bond is present on the second carbon atom. Now this but-2-ene will be oxidized to 2 same aldehydes and then 2 same carboxylic acid groups. So we have CH3COOH, 2 molecules are formed. This is ethanoic acid, so but-2-ene is not the answer. C is 2-methylpropene. In 2-methylpropene we have 3 carbon atoms and on second carbon atom methyl group is attached. Now again 2 products are formed. One is carbon atom having 2 hydrogens, so it will be converted into carbon dioxide, and second one is the carbon having 2 alkyl groups, so it will be converted into ketone. Now part D says 2-methyl-but-1-ene. So the double bond is on first carbon atom and methyl group is on second carbon atom. Again we have 2 hydrogen atom directly attached to the carbon atom having double bond. So this carbon will convert into carbon dioxide while this carbon will convert into ketone. So we have CO2 plus ketone. Now none of these C and D give propanoic acid, so therefore only option that is correct is part A. Question 26. The structure of damascenon is shown. This is damascenon structure. In this structure we have alkene functional groups, carbonyl carbon. Including damascenon, how many stereoisomers exist with this structure formula? So we have to find the stereoisomers. Now there are two types of stereoisomers, one is cis trans and second one is having chiral carbon. In this structure, as we know, there is no chiral carbon because none of the carbon is attached to four different atoms or groups. So the only possibility is the presence of cis trans isomerism. Now cis trans is shown by double bonds. So there are three double bonds present, 1, 2 and 3. The first two alkenes are actually present in the ring structure, so therefore they cannot show cis trans isomerism. The only alkene that can show cis trans isomerism is this double bond. This carbon atom has one hydrogen atom on this side and one hydrogen atom on this carbon atom. So this is the trans isomer of damascene. So the cis isomer will be when two hydrogen atoms are on the same side. So we have cis damascene and trans damascene. So we have two isomers, so therefore option is part B. Question 27. How many isomeric esters have the molecular formula C4H8O2? Now let's draw this esters with this molecular formula. We have HC double bond OO. There are 4 carbon atoms, 2, 3 and 4. Now we can also make another structure, HC double bond OO, CH, CH3. Now the corner carbon has been shifted to this carbon atom, so the structure would be like this. In third structure, we can put a carbon atom on this side. So we have CH3, C double bond O, O, CH2, CH3. We can change the number of carbon atoms on this side. Now, as we have one carbon atom, let's draw with 2 carbon atoms. We have CH3, CH2, C double bond O, O and CH3. Now if we shift this carbon atom to this side, then what happens that this type of structure is formed, CH3, CH2, CH2, C double bond O, O, and only hydrogen atom is left on the other side. Now this is not ester, it is actually carboxylic acid, so therefore this structure will not be counted. Now the only possible structures are 1, 2, 3 and 4, so therefore the possible option is C. Question 28. Ethene reacts with aqueous bromine to give two products. We have bromine atom on these carbon atoms, and in second product you can see one of the atom is bromine and second is hydroxide. Now whenever double bond of bromine is converted into single bond, there is an addition product for Br. So Br is basically added into the alkenes, so therefore this is an addition reaction. A says both products are obtained in this reaction by nucleophilic substitution, so this is not substitution, it is addition. B says both products are obtained in this reaction by nucleophilic addition. Now we know that the double bond of alkene actually converts bromine molecule into poles, so one becomes partial negative, second becomes partial positive. Now the double bonded electrons actually attack the partial positive bromine atom, so therefore this is electrophilic addition, not nucleophilic, so this is also incorrect. C says both products can be hydrolyzed to form same organic compound, and we know that by hydrolysis OH group actually replaces Br group in the 1,2-dibromoethane or 1-bromo-2-hydroxyethane, so therefore this one seems to be correct. D says both products can form hydrogen bonds with water. No, this is incorrect because only this compound can form hydrogen bonds with water, as it has partial negative oxygen and partial positive hydrogen atom. So the only possible option is part C. Question 29. PVC is used as a packaging material. What holds the different polymer strands together in piece of solid polyvinyl chloride? The structure of polyvinyl chloride is like this. We have chlorine atom with one of the carbon atom and 2 hydrogen atoms with other carbon atom. Now this structure repeats itself on and on in polyvinyl chloride. This repetition shows one of the strands of PVC. The other strand will also be like this. So for example, this is the first strand, this is the second strand, this is the third strand. So in between the strand there is no bonding, there are actually weak molecular forces of attraction which are called intermolecular forces. The intermolecular forces are very strong in polymers, therefore polymer stays in the solid form and the chains are also very long. A says covalent bonds, there are no bonds between the strands, actually weak molecular forces. B says hydrogen bonds, for hydrogen bonds we must have fluorine, oxygen or nitrogen. So none of these atoms is present in this strand, therefore hydrogen bond is also wrong. C says ionic bond, there is no ionic bond, only intermolecular forces. And C says van der Waals forces, which is the only possible option. So therefore answer is D. Question 30. The diagram shows the structure of but-1,3-diene. This is the structure of but-1,3-diene and we have two double bonds, one on first carbon atom and second on third carbon atom. The addition reaction between but-1,3-diene and two molecules of HBr can produce three structurally isomeric products. How many of these products have at least one chiral center? Now we know that the chiral center is actually the presence of chiral carbon, and chiral carbon is such a carbon that is attached to four different atoms or groups. Let's first draw the structure of but-1,3-diene. We have CH2 double bond CH, then CH, then double bond CH2. Upon addition of two HBr molecules, we can have products like CH3, CHBr, CH, CH2Br. Or we can also have CH2, Br, CH, H, CH, H, CH2, Br. The third possible structure is CH2, H, CH, Br, CH, Br, CH2, H. The names of these three isomeric products would be, first one is 1,3-di-bromo-butane. Second one is 1 and 4. So it is 1,4-di-bromo-butane. In third one we have bromine atom on second and third carbon atom, so it will be 2,3-di-bromo-butane. Now finding chiral carbon, this carbon is not chiral because it is attached directly with 3 hydrogen atoms. This carbon is chiral because it is attached to one bromine, one CH3, one hydrogen and one group. This carbon is not chiral as it is attached directly to 2 hydrogen atoms. This is also not chiral. Coming to the second one, we have 2 hydrogen with this carbon, so it is not chiral. 2 hydrogen with this carbon, so it is not chiral. 2 hydrogen with this carbon and 2 hydrogen with this carbon. So none of the carbon atoms is chiral in the second structure. In the third structure, we have 2 hydrogen atom on this carbon, so it is not chiral. 1 hydrogen atom on this carbon, so it is chiral because it has 1 bromine atom, 1 CH3, 1 hydrogen and 1 this group. This carbon is also chiral. This carbon has 2 hydrogens, so therefore it is not chiral. So 2 of the products are having at least 1 chiral carbon. So therefore the possible option is part C. Question 31. Scientists are trying to synthesize a new element with proton number 119. The element is predicted to be a group 1 element in period 8 of the periodic table. Which predictions are likely to be correct about this element? 1. The outermost occupied orbital of one atom of this element will be an s orbital. As we know, the group 1 elements always end up in the s orbital and they are called s block elements, so therefore this option is correct. 2. The atomic radius will be the largest of the 7 elements in group 1. As we move down in group 1, the atomic radius increases because in each period one of the shell is increased. So therefore the element in the period 8 will have 8 shells, so therefore it will be the largest in the group 1. This is also correct. 3 says it will have greater first ionization energy than element 118. Now element 118 means one proton is less, so therefore it will belong to group 8. Now group 8 belongs to noble gases, and we know that the noble gases have complete outermost shell. The ionization energy of element 118 would be higher as compared to group 1 element, because element having atomic number 119 has one more shell as compared to group element 118. Therefore this option is not correct, so the only two options are 1 and 2, and therefore answer is B. Question 32. Which reactions would have the reaction profile shown? On y-axis we have energy, on x-axis we have progress of the reaction. These are the reactants, and this is the product. As we can see that the energy of the product is higher than the reactant, so therefore this reaction is endothermic. Option 1, we have sodium hydroxide with HCl. This is a neutralization reaction, and neutralization reaction is exothermic. So therefore this is incorrect. 2 is calcium carbonate, which is decomposed into calcium oxide and carbon dioxide, and therefore decomposition is endothermic, so the reaction is positive. 3rd is the decomposition of magnesium oxide, so it is also endothermic. So both 2 and 3 are endothermic processes, and therefore the answer is part C. Question 33. Which factors can lead to an increase in the rate of a reaction? 1. A lower activation energy. Now we know that activation energy, whenever it is low, the reactants can easily convert into the product, so therefore the rate of reaction increases. Also we can lower activation energy by the addition of a catalyst, so this is true. 2 says an increase in temperature. Now increase in temperature also increases the number of effective collisions, so as the number of effective collisions are increased, the rate of reaction also increases. 3 says an increase in the concentration of reactant. This is also true, because whenever there are more number of molecules of the reactants, there will be more collisions between the reactant molecules and more product is formed within a given specific time. So all 3 options are correct, so therefore answer is A. Question 34. Sodium and fluorine are both reactive elements. 2 atoms are described. 1 atom is of fluorine, second is of sodium. Which statements about these 2 atoms and the ions they can form are correct? 1. One sodium atom has 2 more protons than one fluoride ion. Now we can see there are 11 protons in sodium and 9 protons in fluorine, so therefore sodium has 2 more protons. This is correct. One sodium atom has 2 more neutrons than one fluorine atom. Let's find the number of neutrons. We have 19 minus 9, 10 neutrons for fluorine, 23 minus 11, 12 neutrons for sodium. So there are 2 more neutrons in sodium as compared to fluorine. This is also correct. One sodium ion has the same number of electrons as one fluoride ion. Now fluoride ion has 9 electrons plus 1, 10 electrons, and sodium ion has 11 minus 1, 10 electrons. As both have 10 electrons, so therefore this option is also correct. So all the options 1, 2 and 3 are correct, therefore answer is A. Question 35. In the atmosphere, which transformations can involve sulfur dioxide as either a reagent or a catalyst? 1. NO2 to NO. As this is a reduction reaction, so we can see that sulfur dioxide reacts in the atmosphere with NO2 and converts it into NO, and itself is converted into SO3. So therefore sulfur dioxide can do this reaction, so 1 is correct. Second reaction is NO to NO2. This is oxidation reaction. SO2 cannot oxidize the NO, so this is wrong. Third is carbon monoxide to carbon dioxide. Again it is an oxidation reaction. Sulfur dioxide does not involve in this oxidation, so therefore 2 and 3 are also both wrong. So the only correct option is 1, and therefore answer is D. Question 36. The bond of the HBr molecule is dashed than that of the HI molecule. Which pairs of words correctly complete the above sentences? Let's compare the bond of HBr with HI. We know that bromine is more electronegative, so therefore HBr bond is more strong as compared to HI. Now when electronegative element is present, actually the bond length decreases, so therefore the bond length of HBr is less. than HI. Third is bond polarity. As we know that bromine molecule is more electronegative as compared to iodine, so therefore HBr will be more polar than HI. One says that HBr has greater energy as compared to HI, so this is correct. 2 says HBr has less bond length as compared to HI, this is also correct. 3 says HBr has greater polarity as compared to HI, this is also correct. So all 3 options are correct, therefore answer is A. Question 37, compound X has the structure shown. This is compound X. We can see there are 2 functional group. One is of tertiary alcohol, second is carbonyl carbon of ketone. Which statements about compound X are correct? 1. X will decolorize cold acidified KMnO4. Now, cold acidified KMnO4 cannot oxidize tertiary alcohol. It can also not oxidize or convert ketone group into any compound. So therefore this is wrong. 2. X gives an orange precipitate with 2,4-dinitrophenyl hydrazine reagent. Now we know that 2,4-DNPH is actually used for the presence of carbonyl carbon, whether it is aldehyde or ketone. If carbonyl carbon is present of aldehyde and ketone, then 2,4-DNPH always gives positive result and orange precipitate is formed. In this structure carbonyl carbon is present, so therefore 2 is correct. 3 says X does not react with Tollens reagent. Now Tollens reagent can oxidize aldehyde, but it cannot oxidize ketone. As this says does not react, it means it is true because we have ketone present here, there is no aldehyde, so therefore Tollens reagent will not react. So option 1 is incorrect, only correct options are 2 and 3, therefore answer is C. Question 38, propanol reacts with hydrogen cyanide. Which absorptions are present in the infrared spectrum of the product? Now let's first find the product of the reaction between propanol and hydrogen cyanide. Propanol is aldehyde, we have 3 carbon atoms. It reacts with HCN to give hydroxynitrile as the product. So CN is attached to partial positive carbon atom and double bond oxygen converts into OH later on. So this is the product that is formed. One says a weak absorption in the range 2200 to 2250 per centimeter. From the data booklet we know that this is because of the presence of cyanide. And as cyanide is present in our product, so therefore this is the possible peak. 2. A strong absorption in the range 3200 to 3600 per centimeter. Now from data booklet we know that this peak comes from the presence of hydrogen bonded alcohol, and in our product we also have hydrogen bonded alcohol, so this is the possible peak. 3 says a strong absorption in the range 1040 to 1300 per centimeter. Now this peak is because of the CO bond present in the alcohol. As we have this bond present, so therefore this peak will also be observed. So all 3 options are correct, so therefore answer is A. Question 39. Which alcohols cannot be dehydrated to form alkenes? Now dehydration of alcohols takes place in such a way that OH group is removed from one of the carbon atom and H group is removed from adjacent carbon atom. An alkene is formed along with the removal of water molecule. Now the first option is methanol, as there is only one carbon atom, so therefore we cannot make a double bond between 2 carbon atoms. So this is wrong. Second is tertiary alcohol. We have CH3, 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 OH. So OH group will be removed from this carbon and hydrogen can be removed from this carbon or this carbon or this carbon, and there could be a double bond between any of these. So therefore 2 is correct. 3 is the secondary alcohol. It is CH3, CH, CH3, and OH group is present with the second carbon atom. Now OH group will be removed from this carbon and hydrogen can be removed from this CH3 or from this CH3. So therefore there is the possibility of making a double bond or alkene. So we can say that both 2 and 3 can form alkenes. But the question says which alcohols cannot be dehydrated. So therefore the only option that is correct will be 1 and the answer is D. Question 40, a reaction mechanism is shown. This is the reaction. Which statements about this reaction are correct? One says hydrolytic bond fission occurs. Now we can see the carbon and bromine bond in this one. Now this carbon is attached to 4 groups. One is Br, one is H and 2 are from the ring. Now because of the electronegative bromine atom, it will become partial negative and carbon will become partial positive and bond fission will occur. Now this is hydrolytic bond fission because bromine atom will take both the electrons that are present between carbon and bromine. So bromine is converted into bromide ions as it takes both electrons. So 1 is correct. 2 says it is a substitution reaction. As we can see that OH has replaced Br in the product. So therefore this is an example of substitution. 3 says OH negative behaves as an electrophile. As we can see that in OH we have negative charge and also a lone pair of electron is present. So therefore this is nucleophile, not electrophile. So part 3 is wrong. So option 1 is correct, option 2 is correct. Therefore the answer is B. Thank you for watching. I hope this video was useful. If it is, then please drop a like and subscribe to this channel for more upcoming videos. See you in the next one. Till then, stay happy and keep smiling.